In system design, scalability defines whether a system survives real-world growth. Today we'll focus on horizontal scaling, the primary strategy used by large-scale distributed systems to handle increasing traffic, users, and data reliably by horizontal scaling. In next few sections, we will see the core problem to understanding about horizontal scaling. If you haven't watched my vertical scaling, make sure to watch. It covers some crucial points to scaling. Most systems start with a single server. Initially, performance is acceptable. But as users grow, CPU saturates, memory fills, latency increases, and eventually requests fail. Without a scaling strategy, growth becomes a liability. Horizontal scaling, also called scaling out, means increasing capacity by adding more servers instead of upgrading a single one. Each server runs the same application and shares the workload based on the application needs. Vertical scaling upgrades a single machine with more CPU or memory, whereas horizontal scaling distributes load across many machines. Vertical scaling has hardware limits and single points of failure, while horizontal scaling supports elastic growth. Horizontal scaling removes single points of failure. If one server crashes, others continue serving traffic. A horizontally scaled architecture typically includes a load balancer, multiple identical application servers, and shared backend services, such as databases and caches. Each layer plays a specific role in distributing load and maintaining consistency. The load balancer is the entry point to the system. It receives all incoming requests and distributes them across healthy servers, using algorithms like round-robin or leased connections. This prevents any single server from becoming overloaded. Similar to Kubernetes, we will discuss load balancer in other videos too in detail. For horizontal scaling to work effectively, application servers must be stateless. This means servers do not store user session data or request state locally. Any server should be capable of handling any request at any time. All shared state, such as user sessions, application data, or cached responses, is stored in external systems like databases, distributed caches, or object storage. This separation allows servers to be added or removed without impacting correctness. When a user sends a request, it first reaches the load balancer. The load balancer forwards it to any available server. That server processes the request, interacts with shared services if required, and returns the response to the user. If a server becomes unhealthy or crashes, the load balancer detects this through health checks. Traffic is immediately stopped for that server and rerouted to healthy instances, ensuring high availability, similar to Kubernetes used in the Dockers. In cloud environments, horizontal scaling is often automated. Based on metrics like CPU usage, memory, or request rate, new servers are provisioned automatically and removed when demand decreases. Consider an e-commerce platform during a flash sale. Traffic can increase by several times within minutes. Horizontal scaling allows the system to spin up additional servers instantly, handle the load, and scale back down once traffic normalizes. Horizontal scaling is not an optimization, it is a requirement for production-grade systems. Understanding how and why it works is essential for system design interviews and real-world engineering. Peace out.